All right, hello pre-calculus students. This is Mr. Hazelhorst here, bringing you your Section 5, 5A notes. And today, the purpose of this video is to introduce you to the multiple angle formulas and just do a couple of examples with those. All right, so let's get rocking and rolling here today. All right, so first off, the double angle formulas are listed here on the screen for you. You can see that we have basically a set for sine, cosine, and tangent. I would encourage you at this point to pause the video and write these double angle formulas down in your notes. That's going to be helpful to you as we move forward in Chapter 5 to just have those available. I'll make a quick comment here. If you would like to see the proofs of these formulas, they are on page 397 in your textbook. And then the other comment that I will make is that when it comes to taking your test over Chapter 5, you will not need to have these formulas memorized. We will provide those for you on the test, but it is going to be your job to make sure you know how to use them, all right? And that's what we're going to focus in on here today. All right, so hopefully, again, you've written these formulas down. I'm just going to point out a couple of things about them here. First off, the reason why they are called double angle formulas is you can see that all of them involve the sine of 2 times an angle. All right, that's where they get their name double angle formulas from. And again, the proof to these is on page 397, so I'm not going to spend time kind of talking through that. All right. But again, what we want to focus on is how can we use those. All right. But the key to being able to use these formulas is to recognize again that they come into play when we have a double angle involved, right? The angle that we're using is multiplied by 2, okay? All right, so with that being said, though, let's take a look at a couple of example problems, all right? So the first example problem that I want to walk through is an example where we can use our double angle formula to help us solve an equation, all right? So if we take a look at the equation that we have here, we have 2 cosine x plus 2 sine, and there's the double angle, right, of 2x. All right, now earlier on here in Chapter 5, we talked about how to solve nonlinear trig equations, and we utilized identities, or we factored, all right? Now in this situation, there's not one of our fundamental identities that helps us, and we really can't factor out one of the trig functions to help us solve it either. All right, so this is where our new double angle formulas come into play. All right, so notice that we have a double angle of sine present here. So I'm going to pop up the formula that you wrote down for that double angle of sine. All right, so according to this says that, hey, sine of 2 times an angle is equal to 2 sine of that angle times the cosine of that angle. So I'm going to go ahead and substitute this into the equation. All right, bear with my writing here. All right, so we're going to end up with 2 cosine of x. All right, and then we're going to substitute in the double angle formula for that 2 sine of x. So if I plug that in here, we're going to end up with 2 sine of x. Right, our angle is not u, our angle is x in our equation. All right, and again, all of this is equal to 0. So I'm just going to do a simple little substitution here. We're going to go ahead and multiply this out. So that's going to give me 2 cosine of x plus 4 sine of x cosine of x is equal to 0. All right, and now at this point, we are able to use one of the skills and techniques that we solved our nonlinear trig equations with earlier in the chapter. And so we're going to begin by factoring out a 2 cosine of x. And so that's going to leave us 1 plus 2 sine of x. And so now, once we have factored out that 2 cosine of x, we can set each of these factors equal to 0. And we'll go ahead and solve this trig equation just like we did earlier in the chapter, right? So I'll go ahead and divide both sides by 2 here. That ultimately gives me just cosine of x equals 0. Notice here we're not asked for the complete solutions. We're just asked to find the solutions from 0 to 2 pi. So I know on my unit circle that cosine's value is 0 at pi over 2 and at 3 pi over 2. In our other set here, we'll go ahead and solve for sine of x. So we're going to subtract 1 from both sides, divide by 2. So sine of x is going to equal a negative 1/2. And then again, we go to our knowledge of the unit circle. We know sine is negative. In quadrants 3 and 4, it's going to have a reference angle of pi over 6. And so my solutions there are going to be x is equal to 7 pi over 6 and 11 pi over 6. All right, and so now we've got our 4 solutions between 0 and 2 pi to this trig equation. And again, we just simply used a double angle formula to help us solve this equation. All right, so that is one way that we can use our double angle formulas. All right, the other way is that we can use them to rewrite. All right, so we'll take a problem like this one. And we're going to utilize, again, those double angle formulas. And so we're not solving in this problem. We're just trying to rewrite it. So I'm going to pop up again the double angle formulas for cosine here. And what I want to point out is that we have 3 different formulas that we can use for cosine. The one that applies in this problem is going to be this middle formula right here. All right? Now, if we take a look at the problem that we have to work with, we can see that it's not quite in the form of our double angle. All right? But if I go back up here, I can go ahead and factor out a 2 from this problem. So that's going to leave me 2 cosine squared of x minus 1. And now that double angle formula we can use to rewrite, right? We know that 2 cosine squared x minus 1 is equal to 2 times the cosine of our angle. Our angle is x. And so there would be a way that we could rewrite this problem using a double angle formula. All right, let's take a look at one more of those. So in this problem, we have 2 sine of 4x, cosine of 4x. All right, so if you take a look at your double angle formulas, hopefully the double angle formula that pops out to you is our sine double angle formula. And again, if we take a look at things here, we want to recognize that our angle is 4x, right? So that's really important to recognize in this problem, because if I'm going to rewrite this, everything else matches up, but I need to recognize that u is representing 4x, right? So if I rewrite this using my double angle formula, right, I'm going to end up taking 2 times my angle, again, my angle being 4x. So when I rewrite this, this is just simply going to be the sine of 8x, right? So that's what this first section of Chapter 5 is going to focus on, is those use of the double angle formulas. I hope this video was helpful. Again, make sure you have those double angle formulas written down. Again, remember, you do not need to have them memorized. We'll let you use, or we will give these to you on the test. I hope you guys have a great day, and we'll see you soon.